Hello everyone. Today we'll go over some practice problems for waves. Starting out, what is the amplitude, period, and frequency of the wave drawn below? So the amplitude is the displacement from its equilibrium position. So this can be equal to the peak minus the trough divided by 2. So in this case it goes from positive 5 meters to negative 5 meters. So we have 5 meters minus negative 5 meters divided by 2. This equals 10 divided by 2, or the amplitude is then equal to 5. Now let's find the period. So the period is how long it takes for one full cycle or oscillation to occur. This can also be described as the amount of time it takes to do a cycle divided by the number of cycles. So in this case, we see that there are 2 cycles or full oscillations in 4 seconds. So we have 4 seconds divided by 2 cycles. So this means that the period is then equal to 2 seconds per cycle. So period takes 2 seconds. Now the frequency is just equal to the inverse of the period. So this is equal to 1 over 2. 1 over 2 seconds, but 1 over a second is equal to a hertz. So this means that the frequency is equal to half a hertz. What is the equation describing the wave drawn below? So we can see that the wave starts at its highest point, meaning that this will be a cosine wave. So using the wave equation, know that the y-axis will be equal to the amplitude times it by the cosine times it by omega, or the angular frequency, times it by the x-axis. Now, omega is equal to 2 pi times the frequency, and the x-axis in this case is equal to time, as we see that it's given in the unit seconds. So we can rearrange this and say that the y-axis is equal to the amplitude multiplied by cosine of 2 pi times the frequency times it by time. Now we just need to find the value for the amplitude and the frequency and plug it in. Looking at the wave, we see that it spans from positive 6 meters to negative 6 meters. So we can find the amplitude by taking half of the total span of this wave. So we have 6 minus 6 divided by 2, which is equal to 12 divided by 2, or means that the amplitude is equal to 6. Now to find the frequency of the wave, we see that it oscillates 2 times in 10 seconds. So we have 2 cycles divided by 10 seconds, meaning that the frequency is equal to 1/5 hertz. So let's plug these values into our equation. Now we got that the y-axis is equal to 6 cosine of 2 pi multiplied by 1/5 times it by time. Now simplifying this equation, we get the final answer that the y-axis is equal to 6 cosine 2 pi over 5 multiplied by time. What is the amplitude, period, and frequency of the wave below, and what kind of wave is it? So, the amplitude, we see that the wave goes from positive 5 meters to negative 1 meters. So this can be expressed as 5 minus negative 1 divided by 2, which is equal to 6 divided by 2, or is equal to 3. So the amplitude is equal to 3. Now, for the period, we can see it completes one full cycle or oscillation between 2 seconds and 6 seconds. So we have 6 seconds minus 2 seconds divided by 1 cycle. So this means that the period is 4 seconds per cycle. And the frequency is just equal to 1 over the period. Or in this case, that's equal to 1 over 4 seconds. Which means that the frequency is equal to 1/4 hertz. Now, as for what kind of wave it is, we can see that the oscillations occur perpendicular to the direction of motion, meaning that the oscillations are in the y direction while the wave is traveling in the x direction. So it is a transverse wave. Additionally, we can see that it starts from the halfway or the equilibrium position, meaning that it will be a sine wave, not a cos wave. So it's a transverse sine wave.